In this lecture, we're going to discuss how to create graphs for categorical or qualitative data. We'll discuss vertical bar graphs, Pareto charts, horizontal bar graphs, side-by-side bar graphs, and stacked bar graphs. For pie charts, you want to use them to compare one category of frequencies to all the other frequencies. You're essentially trying to compare a part to a whole. Here's an example for a vertical bar graph and a Pareto chart. It appears that there is a black market developing for incandescent bulbs. In some countries in Europe where these bulbs have been banned already, some entrepreneurs are repackaging them and trying to market them as heat bulbs rather than light bulbs. Ads and packaging materials for compact fluorescent light bulbs proclaim that they use much less energy and last much longer than standard incandescent bulbs. However, if you read the fine print on the packaging or find the notice on the base of each bulb, you'll see that it contains mercury. The first question we would like to answer is which objective contains the highest mercury content. Coming in and looking at the chart, we see that the highest category is residential thermostat. The next question we would like to answer is approximately how much more mercury is in a dental filling than in a CFL. Looking at the chart, we see dental fillings have 500 milligrams and CFLs have 5 milligrams. This creates a difference of 495 milligrams. The last question is how might this graph be misleading? And the answer to this would be the vertical break right here. Breaks along a horizontal axis are not misleading. Breaks along a vertical axis are misleading. So we can say the vertical break in the thermostat category is misleading. The last thing I would like to discuss is the graph itself. If you notice, there are spaces between each category. This creates a bar graph. If there's no spaces present, you get what's called a histogram. Also, this bar graph can be called a Pareto bar graph because the bars go from increasing to decreasing order. Bar graphs that have this shape would not be Pareto because the bars don't go from increasing to decreasing order. An electronic survey of Hillsborough Community College graduates was conducted in which responses were received by 270. Recall, though, that we said 270 was the incorrect total, the correct one's 348. The responses to the open-ended question, please specify where you are continuing your education, are provided below. Remember, we've already created the frequency distribution for this data. I've also come in and added a relative frequency category. The way you get this is to divide your frequency by your grand total. So this number came from dividing 33 by 348. Just to give you another example, if you divided 50 by 348, you'd get your 0.14. So relative frequency, it's a category divided by a total. Let's create a horizontal bar graph for this data. I've created a horizontal bar graph for this data. If you notice, I put the college names along the vertical axis and I put probabilities or relative frequencies along the horizontal axis. I chose to run my relative frequencies from 0 up to 0.3 because in my data set the largest number was 0.26, so I knew 0.3 would be a good stopping point. The bar links correspond to the relative frequencies. So if we come in and look at Hillsborough Community College, it had frequency 0.09, and I've tried to take this bar and line it up the best I could with 0.09 right down here. You'll find the same is true for each of the other categories. For instance, St. Pete College had a relative frequency of 0.26, and I've tried to line that up as best I could down here. One other thing to notice in this graph is that I've left very distinct spaces between the college names. Here there's a distinct gap, same here. You want to leave gaps for categorical data. The bars should not be touching each other. And the last thing to notice is that the bar widths are as close as I could get to being the same size. For instance, this width and this width, I tried as much as I could to make them the same. If you don't have the same widths, your graph will be misleading. Why should we use a horizontal bar graph for the data? Horizontal bar graphs should be used when there's lengthy category names. Approximately what % of students plan to transfer to the University of North Florida? Well, to answer this, you take your relative frequency and multiply it by 100. This gives about 14% of students. If there were 150 students, how many would transfer to St. Pete College? To answer this, take the 150 and multiply it by the relative frequency for St. Pete College, 0.26. This tells us that 39 students would end up transferring to St. Pete College. This is an example of a side-by-side bar graph. Leaf blowers are often rated using cubic feet per minute and miles per hour. The graph below compares the top 5 leaf blower manufacturers based on these two ratings. What brand has the highest CFM rating and what is the rating? If you're looking for CFM, in the graph, it's labeled right here on each of the bars. So out of these 4 bars, the one with the highest CFM would be the Echo leaf blower, and its exact CFM is 765. Next, we would like to know what brand has the highest miles per hour rating. Those are right here on the bars. And the one with the highest miles per hour is Echo at 204. Now the question comes up which rating should be used, cubic feet per minute or miles per hour. Most of us are probably comfortable with the concept of miles per hour. For instance, let's say that I had 2 leaf blowers and they're each blowing at 65 miles per hour. Now what we may not be so comfortable with is the idea of cubic feet per minute. Let's say that these leaf blowers each have different sizes. The first leaf blower may have an opening of this size, and the second leaf blower may have an opening of this size. So then the question comes up, which leaf blower would move more volume per minute? Well, the answer to that would be the one with the larger size. So a higher cubic feet per minute would mean that it's capable of moving more volume per minute. Therefore, we should use the cubic feet per minute rating. Our last example will cover pie charts and stacked bar graphs. Remember, the point of a pie chart is to compare a part to a whole, whereas the point of a bar graph is to compare a part to a part. Correct your notes to read, in 2010, 4 trillion kilowatt hours of electricity were used in the United States. What was the country's most common fuel used to generate the electricity? That would be coal at 45%. Americans used renewable energy sources, water, wood, biofuels, wind, organic waste, geothermal, and sun, to meet about 10% of the total energy needs in 2010. What was the least used renewable energy source? Coming into the renewable energies, composing 10% of our needs in 2010, we see the least used source was solar energy. What percentage of electricity was generated using this renewable energy source? And that would be 1%. These are the works cited used for this lecture.